Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this class, we will discuss about how to draw the cam profiles with roller follower. So the learning outcome is at the end of the lecture, student will be able to construct the cam profile for a given problem with roller follower. Remember one thing, earlier the type of the follower we used to identify is knife edge follower. So the only difference between the knife edge follower and the roller follower is the diameter of the roller, that is being different, right? Now you can identify the problem here. Most of the problem, 90% of the problem will be the same. The only thing is roller will be replaced in the place of knife edge. A cam with minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower. Here the name change. At the end of a valve rod motion described below, to raise the valve through 50 mm. So this 50 mm means the follower moment, right? Or you can call the stroke of the follower. During 120 degrees rotation of the cam, so this is ascent. While reading the problem itself, you need to identify what is what. To keep the valve fully raised through next 30 degrees. So to keep the valve fully raised, that means dwell 1. So after rising by 120 degrees, there you need to make to keep the valve fully raised, that means constant, no change. So dwell 1. To lower the valve during the next 60 degrees, so it is in our language it is descent. And to keep the valve closed during the rest of the revolution 150 degrees, so this will be dwell 2. Next we are having some important data. The diameter of the roller is 20 mm and the diameter of the camshaft is 25 mm. Already it is given a minimum radius of 25 mm. Actually this is redundant, right? Even then it is given. Draw the profile of the cam when first condition. The line of stroke of the valve rod passes through the axis of the camshaft. Just like earlier, this is the rotating the camshaft axis. On the same line, same vertical line, right? Suppose this is the axis of this camshaft and this is rotating like this. Now vertically on this I need to have the follower. So that is called the line of stroke of the valve rod passes through the axis of the camshaft. Passes through means it is actually the intersecting, because this is horizontal and this will be vertical. B. What is the next condition? It is to be left or right offset. The line of stroke is offset 15 mm from the axis of the camshaft. Now the other data you look after this. The displacement of the valve while being raised and lowered is to take place with simple harmonic motion. Now we identify here the ascent and descent, that will be raised and lowered. That means your ascent and descent both are simple harmonic motion. Okay. Next thing, determine the maximum acceleration of the valve rod when the camshaft rotates at 100 rpm. So it is given n value so that you can find omega and the remaining calculations. Draw the displacement, velocity and acceleration diagrams for the complete revolution of the cam. So initially we need to draw the displacement diagram, after that cam profile. We identified lift of the or stroke of the follower is 50 mm. Theta O, this theta O you can write either theta O or theta A or phi O or phi A, or if you want to have any other angle notation, you can take alpha, beta, gamma, anything, right? So why we are making the O or A? O means outstroke. Same thing you are able to call with the A ascent, or you can make the rise, right? All are same. So this outstroke angle is 120 degrees. So it is 2 pi by 3 radians. So this is 2.1 radians, and in the return stroke 60 degrees. So this will be 1.047 radians and n is given 100 rpm. Since the valve is being raised and lowered with simple harmonic motion, it is given. So the displacement diagram is shown in the similar manner as discussed. That means you need to draw a semicircle, divide this into 5 equal parts or 6 equal parts or 8 equal parts, right? So based on the number of parts, you need to draw the horizontal lines and draw the vertical lines from your parts, so that you are able to get your cam profile parts like this. So join all of them, you will get a very smooth curve like this, and G to H, because this is the dwell, the remaining thing again simple harmonic motion, same lines will continue. So this line, you see this line will continue, this line will continue, this is continue, this will continue, right? So one advantage is the same semicircle that could be sufficient for making your ascent and descent graphs. After drawing this, we need to transfer them onto, actually this is all, everything is known to you while we discussed about the cam profile in the case of the knife edge follower. So all these are to be transferred onto the circle lines, right? This one for the calculation. So it is looking slightly different, but the process of construction is one and the same, very slight difference, right? Initially what we need to draw is, don't look after the diagram because it is looking with so many circles, but actually we need not draw the circles completely. So there is one easy way to draw everything. I will show you one by one. Draw a base circle with center O, so this is O, and radius equal to the minimum radius of the cam, 25 mm. It is given minimum radius of the 25 mm only, okay, right. So on the camshaft, you draw the base circle, draw a prime circle with center O and the radius OA should be minimum radius of the cam plus half of the diameter of the roller. Here it is given in the diameter of the roller is 20, so half of that, that means radius of the roller is to be added with 25. Actually we need to draw the complete diagram. This is camshaft and this is the base radius of the cam. So I need to draw the base circle up to this. Earlier what we did, just to remember one thing, earlier we had drawn the base circle like this, and on this axis we identified the point, this is tracing point earlier when this is knife edge follower. Okay, this tracing point we start with the name A, right? So whatever the contact between the follower and the cam, right, it is starting with A, that is called the tracing point. But now the actual movement will start with roller contact, right. So the roller, it continues to roll around this and it is tracing some other curve through its center. So what is the center of the roller? If I draw the roller like this, now where is the tracing point? The tracing point will be here. So this is the point A, I need to complete it. Now you can identify this is the tracing point. So I need to draw like this. If this is the circle, I will rotate like this, but the cam will not be in rotating manner, it will be other than this, right. On this, we are having the cam profile with some variations, right, but we are unable to get this one because we need to complete with the roller, right. So how to continue with the roller, I will tell you one by one. So initially what we did, you completed the circle with this, we completed the base circle, on this we had drawn the prime circle, right. Okay, so the prime circle we completed with this one, we identify very carefully. So earlier it is the base circle, now I completed prime circle. After the prime circle is drawn, what I need to identify? The point A. So this is the tracing point, this is the tracing point, okay. Now after that, draw angle AOS 120 degrees to represent the outstroke of the wall, angle SOT equal to 30 degrees to represent dwell, and angle TOP 60 degrees to represent the lowering or the return stroke of the follower, right. Now on this, after identifying this circle, I need to divide the same circle into sufficient parts. First part will be outstroke, second part will be dwell 1, third part will be return stroke, fourth part will be dwell 2, right. So I will identify this is AOS, this part. I am extending the lines, this is AOS and SOT, this is the dwell part. Now this will be return stroke, this is the return, this is the dwell 1 or delta 1 I will write, and this is outstroke, right. Now the same thing, just what we did earlier, you divide this AOS, that means outstroke, into how many equal parts you did in the displacement diagram? 6 equal parts. Same 6 equal parts you do here, right. So you extend the lines, okay, and you find the points B, C, D, E, F like this. After identifying, divide the angular displacement of the cam during the rise and lower, AOS and TOP, into same number of equal parts as in the displacement diagram. Okay. So join the points 1, 2, 3, etc. You will get with the center O and produce the lines beyond the prime circle as shown in this figure, and set off 1B, 2C, 3D equal to the displacement from the displacement diagram to find. Actually we are getting the profile on prime circle, right? That curve we are calling with the name pitch curve, right? Remember one thing, if it is the knife edge, we are directly getting cam profile on base circle. If it is the roller follower, what we will get? We will get the pitch curve. From the pitch curve, we need to get cam profile on base curve. Okay. So, pitch curve is the intermediate one. Same process. Whatever I am getting cam profile on the base circle, if it is a knife edge, same to same, I will get the same type of profile on roller follower. That will be called as pitch curve. So, from the pitch curve, how to get the cam profile? Actually, we are getting, after completion of this, I will get like this. If you join all the points, then I will get a profile like this. This is the similar type of the profile when I am getting the cam profile on the base circle in the earlier knife edge follower, because this is the tracing point and this is my follower. I think you got the point. Now, because this is the roller follower, what is the actual tracing point? The point of contact between the roller and your base circle, right? Now, what is the real tracing point? This is the real tracing point, right? What is the difference? Radius of the roller, right? So, first initially you need to identify this point, right? After that, we need to identify the same radius of the roller equidistant to all the points of the pitch curve, right? So, it is very difficult for you to identify many points. So, what we need to do is, first we construct the roller circle, right? The same circle is to be copied. So, initially I am taking some mark. Okay, let it be something, right? Now, this is actually the roller, right? This is whatever you are seeing in the pink color, it is the pitch curve, right? So, this is the pitch curve and this point is the tracing point. So, this is actually the point of the cam. So, what I need to draw is same circle, all the points of the pitch curve you repeat as many times, right? Like this. Okay, you repeat as many times. Now, you join the points with a smooth, all the edge points you cut with the compass or the scale, you join all the points very smoothly. Now, this is actual cam profile. I think you are very clear. This is very easy procedure how to draw the cam profile of this. By this, the student can construct the cam profile for the given problem conditions with roller follower. Thank you.